Now let us learn and understand what is annuity. When equal payments are made every month or every year, especially every year, as in equal monthly installments or as in recurring deposit, it is called annuity. There are two types of annuities. First is ordinary annuity, which means that these equal payments are made at the end of each period. For example, at the end of each month or at the end of each year. For example, you take a loan and you start paying the installments at the end of each month, not immediately when you take the loan. So this is called ordinary annuity. While the other type of annuity is the annuity due, which means that equal payments are made, but not at the end of each month, but at the beginning of each month or at the beginning of each year. For example, when you open a recurring deposit account, you deposit a certain amount every month. So when you first deposit that money, the period starts. So this is called annuity due. FVA means future value of an ordinary annuity. Let us say capital R is the value of this annuity. So the formula for the future value of the annuity is given as R multiplied by 1 plus I the whole raised to n minus 1 the whole upon I. Or you can use the table number 3, to get the future value of the interest factor of the annuity, which is also written as FVIFA, and multiply that number with the annuity R, where you can intersect the interest column and the number of years to get this particular number. We're going to understand this in some examples. While future value of annuity due is represented as FVA and due is written as a subscript. The formula for which is almost similar to the formula given above, with the only exception that 1 plus I is also multiplied to it. In the same way, when 1 plus I is multiplied to this particular formula, you get the formula for FVA due. Let us understand this example. What shall be the future value of the annuity of rupees 1 lakh for 5 years at an effective rate of 12% per annum after 5 years, which means that we are going to pay 1 lakh rupees every year for 5 years. So in all we are going to pay 5 lakh rupees, and the rate of interest is 12%. So what will we get after 5 years? This could be an example of a sinking fund or a recurring deposit account. So we are being told that R is 1 lakh, I is 12%, number of years is 5. We write down the formula of FVA, and that is R 1 plus I the whole raised to n minus 1 the whole upon I. Then we substitute in the values. We write 1 lakh over here, we write 12%, we write 12% over here, and we write 5 for the number of years. 1 plus 0.12 is 1.12. 1.12 raised to 5 is 1.76, and that minus 1 is 0.76. When we divide it by 12, we get 6.35, and when we multiply it with 1 lakh, we get 6,35,284 rupees and 70 paisa, which means that we have actually deposited 5 lakh rupees, but we are getting the interest on all these annuities year after year, and in all we are going to get 6,35,000 rupees approximately. We can solve this sum using the table also. So we can intersect the table where 12% and 5 meet, and we get this number directly. The same number is written over here, 6.35, and when we multiply it with 1 lakh, we get 6,35,024. What shall be the future value of an annuity of rupees 1 lakh at the beginning of the year? Means we are depositing 1 lakh right now for 5 years at an effective rate of 12% per annum after 5 years. So this sum is almost similar to the previous one, with the only exception that the beginning of the year is mentioned. So this is annuity due. So we have R as 1 lakh, I 12%, number of years 5. The only difference is that this formula will also have 1 plus I multiplied, and of course a due is written as a subscript. Then we substitute in the numbers, and when we multiply this 1.12 to 1 lakh, we get 1 lakh 12,000. Else everything is the same, and we get 7 lakh 11,518. So the same thing can be done with the help of the table, with the only exception that 1.12 will be multiplied to the previous answer, and we get 7,11,518.86. Now, the present value of an ordinary annuity is represented as PVA. And again, let R be the value of the annuity or the installments. The formula of PVA is a little different. R multiplied with 1 minus 1 plus I the whole raised to minus n the whole upon I. Now, raised to minus n simply means that this 1 plus I is in the reciprocal terms. So it's 1 upon 1 plus I the whole raised to n. And again, if you look at table number 4, we get present value interest factor of an annuity. And we intersect the interest and the number of years column. So we get a number from there. The present value of annuity due can also be written as PVA D. D represents the annuity due after n years. And the formula to which is also similar, just multiply 1 plus I to the previous formula and you get the answer. And similarly, we can use the table also, where 1 plus I is multiplied to table number 4. What is the aggregate present value of rupees 500 received at the end of each of the next 3 years, assuming a discount rate or an interest rate of 4%? So I'm going to get 500 rupees, but not now, at the end of each of the next 3 years. So it is as if I'm receiving a lump sum amount of how many rupees right now? Or in other words, what is the value of the loan that I should be giving to somebody or I should be receiving if the installments are 500 rupees for 3 years and the discount rate or the interest rate is 4%. So the installments are 500, the interest is 4%, number of years is 3, and we use the formula for the present value because we need to find the present value, the value of it right now, as of today. And we write R multiplied by 1 minus 1 plus I the whole raised to minus n the whole upon I. We substitute in the numbers. 1 plus 0.04 is 1.04. Raised to minus 3 can be written as a reciprocal raised to 3. 1.04 raised to 3 is 1.1248. We take the reciprocal, we get 0.888996. We subtract it from 1, we get 0.111. We divide it by 0.04 to get 2.7751. We multiply it with 500 to get 1387.55. Which means if I'm going to get a loan of 1387 approximately, I'll be repaying 500 rupees for the next 3 years. So I'm going to repay 1500 rupees. But the value of the loan as of today is only 1387. Again, you can use the table. And if you intersect the 4% with 3 years, you're going to get 2.77 multiplied with 500 to get the same number. Determine the present value of an annuity. Again, we need to find the present value. The annuity is 1 lakh rupees, receivable for 5 years, the number of years is 5, at an effective rate of 12%, that's the interest. If annuity is receivable at the beginning of the year, so this is annuity due, R is 1 lakh, I is 12%, number of years is 5. We are going to use the formula for annuity due, just multiply 1 plus I, that's the only thing extra. We substitute in the numbers. And we get 4 lakh 3,734 and 89. Again, using the tables, R is 1 lakh. If you look at the table, it will give us 3.60478, and multiplied with 1 plus I, which is 1.12. to get again the same answer. At the end of 6 years, how much is an initial rupees 500 deposit, followed by 5-year and annual rupees 100 payments worth, assuming a compound interest rate of 10%. So there are two parts to the sum. First, we are going to make a deposit of 500 right now. So how much will I get after 6 years considering 10% interest? And the second part is, after 1 year, I'm going to make 100 rupee annual deposit. So that's my annuity, but after 1 year. So I'm going to make this 100 rupee deposit for 5 years, again at 10%. So it is an example of annuity due, because I'm going to make a payment first and then the 5 years are going to be started. So first part is, I'm going to make a payment of rupees 500 right now. So that's the present value or the principal. The rate of interest is 10%. Number of years is 6. Just use the simple formula. Amount is equal to principal into 1 plus I the whole raised to n. And substitute in the numbers to get 885 rupees and 78 paisa. So 500 rupees as of today will be 885 rupees after 6 years. But then I'm going to make an annuity payment of rupees 100 but after 1 year for 5 years. So the rate of interest is 10, number of years 5. I'm going to use a form for annuity due, because first I'm going to make a payment and then the 5 years are going to start. Again, substitute in all these numbers to get 671 and 56 paisa. So I'm going to make a payment of 100 rupees for 5 years. So I'm going to make a payment of 500 rupees, which will turn out to be 671 rupees and 56 paisa after 5 years and after 6 years as of today. While the initial deposit of 500 will give me 885 rupees and 78 paisa. So the total future value will be 1557 rupees and 34 paisa. What rate of interest is needed for a deposit of rupees 35,000 to grow into rupees 86,450 in 8 years, assuming annual compounding? Which means this is the present value, which will turn into a future value of 86,000, but after 8 years. So you need to tell what should be the rate of interest, so that this present value of 35,000 becomes a future value of 86,000. So let that interest rate be x. So that interest rate when multiplied to 35,000 will give us 86,450. So the value of x is, when we divide these numbers, is 2.47. Now when we search horizontally across table 1 at an 8-year mark, because the number of years was 8, and we get this particular thing. 12% is 2.47, which is very close to this, 2.4759, and 15% is 3.05. So since 2.47, 2.475963 are very close, we can say that the interest percent was very close to 12%. So we are getting a 12% interest per annum. What rate of interest is needed for a deposit of 35,000? Again, the present value is 35,000, that's the principal. To grow into 1 lakh rupees, that's the future value, that's the amount I'm going to get after 8 years, assuming annual compounding. So only difference is that we have a different future value this time. So 35,000x is equal to 1 lakh. So the value of x is 2.85714. Now, this time again, if we search in table number 1 at the 8-year mark, because the number of years is 8, we get 12% is 2.47 like we saw in the previous example, and 15% is 3.05. But we require 2.85, which we do not see in this particular table. So what should we do? So we can deduce that if 12% interest corresponds to 2.47 and 15% corresponds to 3.05, some x percent or some sub percent, not to confuse with this x, some x percent or some I percent will be equal to 0.85, this particular number. So we should have written I plus over here. But anyhow, we can use this particular logic. If x minus 12 corresponds to 2.85 minus 2.47, as I've written over here, it should be equal to 15 minus x, corresponding to 3.05 minus 2.85, which I've written over here. I'm just using the first two decimal places after the decimal point, which should be equal to 15 minus 12%, the whole upon 3.05 minus 2.47. So you can see that the first two proportions or ratios have x term in it, while this particular proportion does not have any x term in it. So what are we going to do? We're going to take the first one and the last one. So x minus 12 is as it is. We subtract these two to get 0.38. 15 minus 12 is 3. And we subtract these two to get 0.58. And then we take this 0.38 and cross multiply over here. And on solving these numbers, we get 1.96. Minus 12 goes on the other side to get plus 12. 12 plus 1.96 is 13.96. So this x percent is 14% approximately. A machine costs rupees 30 lakhs today. So that's the present value of the machine. The cash inflows in lakhs expected at the end of the respective years is shown in this particular table. So I'm going to buy a machine today, and that machine is going to cost me 30 lakh rupees. And I'm expecting that after first year, I'm not going to make any profit. But I'm going to start making profits from the second year onwards. So after the end of year 2, I'm going to earn, let's say, 10 lakh rupees. At the end of year 3, maybe 15 lakh rupees. This is just an estimate. After the 4th year, I'm going to earn 12 lakh rupees, and after 5th year, I'm going to earn 16 lakh rupees. And the cost of the capital is 10%. That's the market value. So if I'm not having that 30 lakh rupees as of today, I can get it at 10% per annum. And this particular table shows the present value of rupees 1 at 10%. So at the end of first year, the present value factor is 0.91. After 2 years, it's 0.83 and so on. So we need to advise the management whether the machine should be bought using the net present value method. So we're going to make such a table. So let me explain to you what are we doing. So we are making these columns year, cash inflow, present value factor, and present value. So after the end of first year, I'm not going to earn any profit. That's just an estimate, the 0. But after the end of year 2, it is estimated that we are going to earn 10 lakh rupees in that year. After the end of 3 year, 15 lakh rupees, 4th year, 12 lakhs, and after the end of 5 years, 16 lakh. So the present value factor is 0.91, which I've written over here, 0.83 over here, and so on. And then we are multiplying these two numbers to get 0. 10 into 0.83 is 8.3 lakhs. 15 into 0.75 is 11.25 lakhs. So what is the meaning of this? The meaning of this is, though I'm going to get 10 lakh rupees after 2 years, it is as if I'm getting only 8 lakh and 30,000 rupees today. That's the present value of the 10 lakh that I'm going to receive after 2 years. So that's the present value factor multiplied by 10. Though I'm going to get 15 lakh rupees after 3 years, what if I'm going to get it today? It is as if I'm going to get 11 lakh and 25,000 rupees today itself, and not 15 lakh rupees. So the 12 lakhs after 4 years is as if we are getting 8 lakh rupees today. And 16 lakhs after 5 years is as if we are going to get 9 lakh 92,000 rupees today. And of course, we are not going to get any money after the first year, so the present value today is also 0. And if we add all these incomes, we are going to get 37 lakh 63,000 rupees. So the total money that we are going to earn for 5 years is as if we are earning 37 lakh 63,000 rupees today itself. And the investment today is 30 lakh rupees. So that means this is a profitable thing. The net present value is a positive 7,63,000 rupees, which is the difference of these two. So, since the net present value is positive, we can say that the machine can be bought. But if these numbers were a little less, then it would be advisable that the machine be not bought. Perpetuity is an annuity in which equal payments or receipts begin on a fixed date and then they go on forever. Which means that whatever money you're going to give, let's say to the government or to the bank or to any person, you're not going to get back the money anytime. So the present value is almost zero. But you're going to get the annuities every year or every month throughout your lifetime. Throughout your lifetime. So the formula for present value of an annuity with a subscript of infinity is R upon I, which means you're not going to get your principal back, but you're going to get the interest forever and ever and ever. So a man wants a fixed income of 15,000 per year per annum for his entire lifetime. The interest percent in the market is 5% per annum. So how much should he invest in this perpetuity annuity or account? So we write down the formula R upon I, substitute 15,000 upon 0.05 to get 3 lakh rupees. So if he's investing rupees 3 lakh rupees, he's going to get 15,000 every year for his entire lifetime and even afterwards. What will be the annual installment of a loan of rupees 5 lakh, which is given at the rate of 10% per annum for a period of 5 years? Set up a loan amortization table. So the present value, this is the principal. Principal is always the present value, is 5 lakh rupees. Interest percent is 10%. Number of years is 5. What is the installment that needs to be paid? So we use the present value of the annuity because we have been told the present value is 5 lakh rupees, and we write that formula. We substitute in the numbers to get the following answer. So we get the annuity every year is 1,31,900. Remember, when you divide these two numbers, you're not going to get exactly some particular number. So we are approximating it to the nearest tens. So we need to pay 1,31,900 every year for 5 years so that we can avail a loan of 5 lakh today itself. So now let us see how to make that amortization table. So in this amortization table, you see we make columns like year, beginning loan balance, annual installment, annual interest, principal repayment, and the ending loan balance. So for the first year, the beginning loan balance is 5 lakh rupees. That is the present value. That is the principal that we are going to get. The annual installment is 1,31,900. The interest was 10% per annum. So we are calculating the interest on this 5 lakh, which gives us 50,000 for the first year. So we paid an annual installment of 1,31,900, out of which 50,000 was only interest. So the remaining 81,900 was the principal. So we have paid a principal of 81,900 out of the 5 lakh rupees. So 5 lakh minus 81,900 gives us 418,100. So this is the ending loan balance for year 1, which also becomes the beginning loan balance or the starting loan balance for the year 2. Again, we are going to pay the fixed installment, the annuity, 131,900. But this time, the annual interest will be calculated on 418,100. So the 10% of this is 41,810. Now, out of 131,900, 41,810 was considered as interest. So remaining 90,090 rupees was considered as the principal. So if we subtract 418,100 and 90,090 rupees, we get 328 and 10. Then this 328.10 becomes the ending loan balance for year 2, but the starting loan balance for year 3. Again, taking the installment of 131,900, which is always fixed, we calculate 10% of this beginning loan balance to get this annual interest. We subtract these two to get 99,000 as the principal, and then we subtract this and this to get the ending loan balance, which is again repeated. 10% of this is 22,000. This minus this gives us this. This minus this gives us this. And finally, for year 5, the beginning loan balance was 1,19,902, and out of which the annual installment of 131,900 was paid. So interest was calculated on this. Remember, we have rounded out to the nearest integer, and subtracting the numbers, we get a principal repayment of 119,910. So in the final year, we paid a principal of 1,19,000. In the first year, out of this annual installment, only 81,000 went towards the principal, but towards the end, a lot of money went towards the principal. The annual interest kept on reducing while the principal repayment kept on increasing. And when you subtract the numbers, we get a -8. This -8 should actually be 0, but this is because of that rounding off error.